Hello, this is lesson 10.2, day 1. We're going to be talking about parabolas in this lesson, but we need to be reminded about total, conics, like all the types. You can see in this figure that we have circle, ellipse, parabola, and hyperbola. These conic sections are formed when you have a plane intersecting a double-napped cone. So you can see the two cones that are joined at their vertices there. And in the formation of the four conics in that first line there, we can see when we have the intersection of the plane at different angles to the particular cone, or cones in the case of a hyperbola, we get the conics that are formed. In the bottom row there, if the actual plane intersects the vertex of the cone, we have what are called degenerate conics. And you can see there if it just intersects at the one point, or if it intersects at the whole, kind of that slant height of the cone, then you get just a line, and then the two intersecting lines is if you've got straight through and through the vertex and both cones. We need to look at the basic formula and the definition, so you'll need to write all of this down. But first, the definition of the parabola. There are points x and y that are in that plane equidistant from a fixed line called the directrix, and the fixed point called the focus that's not on the line. You can see that in that, referring to the figure there. The midpoint between the focus and the directrix is called that vertex. You can see that in that figure as well. The line passing through the focus and the vertex is called the axis. We remember that it's symmetrical. It's symmetrical across a particular axis of symmetry, we call it. So you see this parabola is symmetric with respect to the y-axis on this particular one. We will be dealing with vertical and horizontal parabolas, so we're going to be talking about both of those types. Using that definition, you can derive the standard form of the equation of the parabola, whose directrix is parallel to the x-axis or to the y-axis. And here's where we're going to see for vertical and horizontal. So the vertical axis type, recall that the vertex of the conic, in this one particular parabola, is h comma k. That's what they give the coordinates for the vertex as. The x minus h squared equals 4p times y minus k. P cannot be 0. And they give you the information there. That's when it's a vertical axis, and the directrix is y equals k minus p. The horizontal axis equation, y minus k, quantity squared, equals 4p times x minus h, and p cannot be 0 yet again. And the directrix for the horizontal type is x equals h minus p. The focus lies on the axis, p units from the vertex, and it says the directed distance. Okay, so if our p value is negative, then depending on vertical or horizontal, it would either go down or left, depending on, for vertical it go down and horizontal goes left. If the vertex is at the origin, then we have two equations, x squared equals 4py and y squared equals 4px. If the center, or the vertex, is the origin. I'll give you another minute to write those. So we're going to look next at a couple of different, all the types that we're going to see. The vertical type are the first two pictures there. Can either open up or down. That's dependent upon your the sign and the p value. Basically, if p is negative, then it opens down. If p is positive, it opens up. You can see those two in the picture located there. The opening right and left, those are your horizontal axis type when the y part is squared in the equation, and that's, you can see it's opening right when p is positive and when it's opening left when p is negative. should recall this information from Algebra 2 as well. We're going to look at some problems from the assignment that you're going to have tomorrow for classwork, or Monday rather, this is the weekend. We'll check out those